Okay, level 2 chemistry. Welcome to further discussion around reduction oxidation reactions, which we will now discuss as redox reactions. Okay, so looking at electron transfer, which is at the heart of redox chemistry. So as you're fully aware as young budding chemists, all elements contain electrons. And the discovery of electron led to a modern new definition of redox recently in the last 100 years. In essence, if an atom loses electrons, it is being oxidized, and at the same time, if an atom is gaining electrons, it is being reduced. And we can summarize this with a wonderful mnemonic called oil rig, where oxidation is loss of electrons and reduction is gain of electrons. If you're more in line with the animal kingdom, you can also use Leo Ger, where loss of electrons is oxidation and gain of electrons is reduction. So moving along, essentially redox chemistry is electron transfer from one atom to another. So for each of the following statements, is it oxidation, which is a loss of electrons, or reduction, a gain of electrons, which is taking place? So I want you to pause the video now and work through A to H by yourself, and if you desire to, you can write the answers down and I can mark them in class for you. Okay, so welcome back. The next aspect of redox chemistry is the noble half equation. And half equations record half of what is happening in a redox reaction with electrons, because as we are now aware, redox reactions involve a reduction reaction and simultaneously a oxidation reaction. Okay, and some important rules developed around the writing of half equations. They are always add electrons to the most positive side to make the same charge overall. So for example, here we have magnesium going to magnesium 2 plus ion. So therefore, as magnesium has no charge and the right hand side has a positive 2 charge, electrons, which are always negative, must be added to the right in order to make it equal. So that means there will be no charge on the right and also no charge on the left. So the half equation would be magnesium going to magnesium 2 plus and 2 electrons. So here we have 4 other examples on this slide. I want you now to pause the video and complete them in your own time. And if you wish to get answers or discuss them with me, you can show me in class and we can go over it. Okay, so welcome back again. So here's some more half equations which you can work on in your own time and show me in class so we can discuss it. Point G, please note that you'll need to balance the oxygen before you start adding electrons for this particular example. Okay, so moving right along. So in order to gain excellence in this unit or achievement standard, you have to be able to add the half equations together to make a whole redox equation. Okay, so the 2 half equations for the oxidation and reduction, 1 half equation for each step, comes together to make a whole equation. So before adding them together, it is very important that the number of electrons have to be the same for each half equation. In this case, on the left hand side or right side of the arrow, depending if it's an oxidation half reaction or a reduction half equation. And here's an example here on this slide. So we have sodium being formed into the sodium ion plus an electron. So you need to double that so you get 2 electrons, because in the other half equation, the chlorine gas is gaining 2 electrons. It's being reduced to 2 chloride ions. Okay, so in terms of the whole equation, the 2 are added together in which the electrons in the half equations can be cancelled out. Okay, so the overall reaction becomes 2 sodium plus chlorine gas, giving 2 sodium ions plus 2 chloride ions. Okay, so here's 2 other examples on this slide. I want you to pause the video right now, work through them in your own time, and if you desire to. If you don't quite understand what's going on, you can show me what you've done in class and we can go over it together. Okay, so here are 3 other examples of adding half equations. So as with the previous examples on the last slide, I want you to work through it in your own time, pausing the video and showing me, if you're having problems with it, your results, and we can go through it and discuss it together. And we can go towards achieving an excellence in this unit. Okay, another aspect, especially around the achieve level to begin with, is you have to recognize which are the oxidants and which are the reductants. Okay, so it's 2 main definitions around this. A substance that is reduced, which means it's gaining electrons, is known as the oxidant, and a substance that is being oxidized or losing electrons is called the reductant. Okay, so for the half equation of the sodium going to sodium ion and chlorine gas going to 2 chloride ions, in which we've now balanced to give 2 sodium plus chlorine, giving sodium ions and 2 chloride ions, we need to be able to circle the oxidant and put a rectangle around the reductant in the whole equation. Okay, this is part of the unit standard. I need to be aware that you understand the difference. Okay, so a simple rule for this is that, remember the 3 R's. Electrons are on the right, it equals a reductant, so you put a rectangle around it. So in the example of the sodium and chloride reaction, the reductant would be the sodium and the chloride gas would be the oxidant. And halogens are very well known oxidizing agents. Okay, so this is a small infographic for redox for those of you who are more visual learners. So as you can see here, the reducing agent has been oxidized by losing its electrons, and the oxidizing agent has been reduced by gaining electrons. Okay, that's just another way of visually representing what was in the previous slide. Okay, so as I'm a little bit of a evil teacher, I'm going to give you more complex half equations to push you as students. So some elements for more complex ions. Okay, for instance, the permanganate. Okay, this involves more than one element. So in order to write a half equation for this, we need to follow 4 steps in order. The first step you have to do is you have to balance the atoms that are not oxygen and hydrogen. Okay, the second step is that you have to balance the oxygens by this time adding water. The third step, you have to balance the hydrogens by adding the proton ions. And the fourth step is you balance the charge by adding electrons finally to the most positive side. You then add the half equations to make a whole equation, but you first have to make sure there are equal numbers of electrons on both sides. Okay, so you've got to multiply one of the half equations to make sure the electrons on the right hand side equal the electrons on the left hand side so they can cancel out. Okay, so here's an example that I'm going to give. So it's going to be manganese 2 plus going to permanganate. Okay, so the first step, nothing has to change because you've got manganese on both sides. In the second step, you add 4 waters to the left hand side because there is 4 oxygens on the right hand side. Okay, so that's why you need to add the 4 waters, because that gives you the 4 oxygens. The third step is you have to balance the hydrogens by adding the protons. So you can see on the left hand side initially there is 4 times 2, 8 hydrogens. So on the right hand side you have to add the 8 protons to make the hydrogens balance out. And finally, to balance the charge, you have to add electrons to the most positive side. So on the left hand side we have manganese 2 plus water, which has no charge, so the overall charge on the left hand side is plus 2. And initially the overall charge on the left hand side is minus 1 plus 8, so that's minus 7, plus 7. So you need to add 5 electrons, or plus 9, sorry. You then have to add 5 electrons because plus 9 plus 5 negative gives you the plus 2, which you see on the left hand side. Okay, so that means the charge now balances out. So now I want you to practice some more complex half equations here. Remembering, of course, you don't have to use all the steps if it's not necessary. Okay, so work through these And if you're having any problems, you can come and see me in class and we can go through it together as before. Okay, so now we're going to pull it all together. Okay, so for your unit standard, you're going to have to identify which species you started with in a reaction and which you will finish with. Okay, that's the first thing you're going to have to do. Then you'll have to write a half equation for reduction and oxidation steps. Then you'll add the two equations together to make a whole equation. That's going to be in your merit and excellence area, or more in your merit area. And finally, you will circle an oxidant and put a rectangle around the reductant. So for those students aiming for excellence, which should be all of you, you will need to justify your choice of an oxidant and reductant in terms of loss or gain of electrons. Okay, so you're going to have to say, for instance, this is an oxidant because it is reduced and gained electrons, remembering oil rig, or this is a reductant because it is oxidized and lost electrons. Okay, so here is a table that you're going to have to memorize. Okay, you're going to have to memorize this table, and there's a few important points about the table. You have to match the oxidized form of the element with the reduced form, and a tricky one to remember is hydrogen peroxide, okay, because this can be oxidized to oxygen or reduced to water, and this is where your observational chemistry comes into. Okay, so to figure out the product for a hydrogen peroxide, you'll need to look at the half equation and also look at observations. Okay, so if you're seeing bubbles, then chances are you're looking at oxygen. Okay, so it's being oxidized to oxygen. Whereas if you're not, it's probably being reduced to water. Okay, so just reinforcing that, if it's a reduction equation, you'll need oxygen as the product, and if it's oxidation, you will need water. Okay, so finally, in order to practice for our practice assessments, which are going to come up in week 3 and week 4, whenever these ions appear, you'll ignore them. Sodium, potassium, and nitrate. They're known as spectator ions, and we've already gone through that earlier in the year. Okay, whenever you have ion 2 or ion 3, choose the ion to use and ignore whatever it's with. Okay, so for this case, sulfate or nitrate. If hydrogen peroxide is being used, if it bubbles, then chances are it's going to be oxygen, and if it's no gas, it's going to be water. Okay, this is why it's important to record your observations during the assessment. Okay, so you're going to record what you see. So for example, purple goes to gas. That could be a certain reduction or oxidation reaction. Okay, so you need to explain by referring to the redox species. Okay, you've got to link the ion with the color. So for instance, for permanganate, it's going to be purple. Okay, so that's the manganese 7. And manganese 2 plus is colorless. Okay, so hopefully that's enough information about the standard. If you have any further questions, do not hesitate to get in contact with me, and good luck. Though you won't need good luck because you're going to prepare.